Hey guys, sorry I couldn't be with you today, but we do need to move on, so we're skipping chapter 9. It's not horribly important stuff. 10 is more important, 11 is more important, so we're going to skip to the things that we just have to get to. So this chapter is all about measuring two-dimensional figures. I know you've studied perimeter before. I know you've studied circumference. I know you've studied area before. So you should already know how to find area of a rectangle, base times height or length times width. You probably have already done parallelograms and triangles, but I'm going to assume that we may still have some struggles finding the correct parts to substitute into the formula. So we're going to do a real quick review of the formulas and how to use them correctly. Take good notes. You have to use your own brain, your own notes, and at best, your classmates to get through the assignment for today. So make sure you jot everything down. So a parallelogram, we studied those back in chapter 6, has two sets of opposite parallel sides. Those opposite sides are also the same length, which means we don't need to know all the measures of a parallelogram in order to find a perimeter or an area of it. Now, perimeter is pretty simple. You just add all the sides together and you're finished. Area is a little more complicated. So the first thing we need is a formula. In words, the area of a parallelogram is the product of the base and height, but symbols is more friendly. So A is for area. Area equals base times height is the formula that we would use. You need to know that the height is the distance between the bases, and the height is perpendicular to the bases. That big fancy word that you haven't seen for a while means you should be looking for a right angle in order to find the height of a parallelogram. Now, depending on how your measurements are given, you could have one of two sets of bases. You could turn your figure this way, and this side, the two short sides, could be your bases, and you could have a height drawn between those two bases. So you might have to turn your paper around occasionally to see your bases. Most of the time, though, they're drawn so that the bases are on the top and the bottom. So in this example, we'll let the bases be the top and the bottom. Let's say that we have a parallelogram with sides that are, short sides, let's say, are 12 inches, and that means both of the short sides have to be 12 inches, and the long sides are 20 inches, which means both sides are 20 inches. Now, if we want to find the area of this one, we don't have enough information yet, because nowhere in this figure do I have a right angle. So I could make the 20s the bases, I could even make the 12s the bases, but unless I know a height, a distance between the bases, I still don't have enough information. So let's say that we know the distance from the top left-hand corner straight down to the bottom, and that makes a right angle, because distance is always perpendicular to a side. And that distance, well, it's got to be shorter than 12, so let's say that distance is 11 inches. That's the height that we need. So you're never going to use this side of 12 because it isn't perpendicular to a base, but your 11 and your 20 on the bottom, they make a right angle. And those are the two measurements you need. So let's apply the formula. Area equals base times height. The base has to be a side, so the base can't be the 11. The base has to be the 20 on the bottom. 20 inches times the height, which is 11 inches, and 20 times 11 is 220. So this is 220, and inches times inches is inches squared. Area measures how much space is in a figure, which is a two-dimensional measurement, not a linear measurement, so we always measure that in square units. So make extra sure that your units have squares on them. You don't have to write inches times inches when you do the work. You can just write 20 times 11, but you've got to remember to put your units on the end. So the area of this parallelogram is 220 square inches. All right, another example. Let's say this time we have a parallelogram that on the bottom is 5 meters. Up the left side is 12 meters. which means the top is 5 and the right side is 12 as well. Now this time we have this kind of quirky dotted line attached to the outside. You need to know that dotted lines are not part of the figure. The solid lines make the actual geometric figure, so this is a parallelogram. The dotted lines are called auxiliary lines, which means they just help us find measurements, but they aren't actually part of the figure. You don't want the area of the space within the dotted lines. What we do need, though, is a right angle measure. So we're going to stick a right angle in this bottom right-hand corner of the dotted section. We need a measurement that's perpendicular to this base of 5. Now the 5 is just the solid part, which is the only part that you need because the dotted part is not part of the figure. If we know the height of the parallelogram, it means we have to know the distance from the base, which is down here sort of lined up with this 5-meter side, all the way up to the top opposite corner. Let's say that that measurement is 10 meters. So the height of this one is 10 meters, and it's along the dotted line. It's not actually a side of the parallelogram. So the base is 5, and then at a right angle to the base is the 10. That's your H. So area equals 5 times 10, base times height, which is equal to 50. Now technically we did meters times meters, which is meters squared. So 50 square meters is your final area. If the two measures you substitute into your formula do not meet at a right angle, you have the wrong measurements. That is your bottom line test. Okay, so if you take a parallelogram and you chop it in half, and don't do this on your paper, just look. If you take, say, this parallelogram here, and you cut it in half with a diagonal, and you wanted to know only the area of one half of that, that's actually a triangle. So if you take your area formula, base times height, and you take just half of it, you get an area of a triangle with the same base and the same height. So the triangle formula says that the area of a triangle is half the product of the base and the height. In symbols, that's A equals 1/2 times the base times the height. That's a must-know formula for all standardized tests. That's one you need to commit to memory, along with the base times height for the parallelogram. Some reminders here. The height is the distance from the base to the opposite vertex. So in this first picture of the triangle, if I want to know the height from the bottom to the top of the triangle, then I'm going to go from the base of the triangle up to the opposite vertex, the opposite corner. It's perpendicular to the base, the height is, always. B's and H's always make right angles. And the height may or may not be a side of the triangle. Most of the time it isn't. So in this first example, let's say that the bottom of the triangle is 20 feet. The left side of the triangle is 23 feet. And let's say that that's all we know so far. That's still not enough information to find the area. Even if we know the third side, that still isn't enough information because bases and heights have to make right angles, and so far I don't have a right angle in sight. So what I need is either the distance from this 23 feet over to the opposite vertex, or the distance from 20 feet to the opposite vertex, which is the one that I usually like to look at, even if I have to turn my picture around. From the top to the bottom at a right angle measures how tall the triangle is. That's your height. Let's say in this particular case that height is 15 feet. The 23 feet is of no use to us. We need the bottom, that's the base, the whole thing, times the height, and then we have to take half of it. So area equals 1/2 times the base, that's 20, times the height, that's 15. You've got a couple of options for how to finish this. There's the long way, which is to type it all in the calculator, and there's the short way, which is to do it with your brain. Half of 20 is 10. 10 times 15 is 150. Now we do have 20 feet times 15 feet, and feet times feet is feet squared. So 150 square feet is the area of that triangle. Often you'll have measurements that you don't use at all. Don't try to use all the numbers on the figure, only use the ones that you need. So when you have an acute triangle like this one, normally the base is a side and the height is not a side. It's some measure inside the picture, inside the triangle. Sometimes we get an obtuse triangle like the one in the middle. Okay? Another problem with this triangle is that it doesn't have a right angle built in. And there's not an easy way to go from, say, the bottom side to the opposite corner and make a right angle. That's kind of awkward. So what normally happens with obtuse triangles is that there are some auxiliary lines that are drawn outside the figure, and those auxiliary lines give us the measurement of the height. So let's say that the bottom of the triangle itself, the solid line, is 10 millimeters. This longest side is 18 millimeters, and the vertical dotted measurement is, let's say that's about 12 millimeters. In order to find the area of the solid part, which is the triangle we started with, we need two measurements that make a right angle. The 10 millimeter measurement makes a right angle with the 12 millimeter measurement. The 10 has to be a base has to be a side of the triangle, and the 12 would be how tall it is. That's your height. So area equals 1/2 times the base of 10 times the height of 12. Okay, you could use a calculator or you could use your head. Half of 10 is 5. 5 times 12 is 60. Or, since multiplication can be done in any order, you could do 10 times 12 is 120 and then take half of 120. You still get a 60. It's just a different way to get there. And millimeters times millimeters is millimeters squared. Okay, the last case is a case when we have an actual right triangle. So we saw an acute triangle, an obtuse triangle, now we're going to see a right triangle. Let's say that this right triangle has a base of 12 and a hypotenuse of 13. And I want to find its area. And the area is 1/2 times the base times the height. Well, the base could be 12, but 13 can't be the height. So that's not helpful. Oh, but there's a right angle here. It's built in. It's already there. So the height could be how tall the triangle is along this leg. Let's see. Blank, 12, 13. That's a Pythagorean triple. This missing side is 5 because 5 squared plus 12 squared is 13 squared. So it turns out the height is 5. And the base can be 12 because they make a right angle with each other. You also could turn it around this way. Crazy but true. You could let 5 be the base and 12 be the height. You still get the same product when you multiply them, so it really doesn't matter. So when you have a right triangle, you can just use your legs. So let's let the base be 12. Let's let the height be 5. Half of 12 is 6. 6 times 5 is 30. And this time I don't actually have known units. When I don't have known units, I'm going to simply write the word units with a square. We'll use a generic label. Alright, so that's pretty much it for the formulas. Area of a parallelogram, area of a triangle will get us done for the day. I'm going to add one more example in for good measure. Sometimes you have figures that you need to find areas of that are combinations of other things. So this one is a combination of a rectangle, which you could think of as a special parallelogram, times a triangle. So when I do combined figures, I need to do the separate parts. So I'm going to start with the rectangle. So area of this rectangle is base times height. The base of it, I'm going to let that be 24. And I'm assuming this is sort of a house, so there's probably a right angle down there in the bottom corner, which means the height should be 8. I don't want the 12, I only want the height of the rectangle section. So we're only doing the rectangle so far. So 24 times 8, and 24 times 8 is 192 square feet. So that's the area of the rectangular part. Then we can do the area of the triangular part. Now the triangle, its base is still 24 because it spans the same distance as the bottom of the house. This base is 24, and its height from the 24-inch or foot side up to the top, making a right angle. You have to figure out how long that is. Well, the house is from bottom all the way to the top 12 feet. If the distance from the bottom to the top of the rectangular part is 8, that means there's 4 more feet above that. So that means this height is 4 feet. So this triangle has an area of 1/2 times a base of 24 times a height of 4. Half of 24 is 12. 12 times 4 is 48 square feet. So the triangle has an area of 24 square feet. I'm sorry, I didn't say that right. 48 square feet. Alright, to get the area of the entire figure, you have to add your parts. So the total area is the 192 for the rectangle plus the 48 for the triangle. Let's see, 2 plus 8 is 10. If we carry a 1, we get 24. That's 240 square feet total in the figure. So you don't need a bunch of fancy schmancy formulas to solve these kinds of problems. You can really get by with 2 formulas for anything except circles, because parallelograms and triangles, you can split any kind of a straight-sided figure up into those and combine the parts and do this procedure. Alright, you have a worksheet of practice problems to do. Help each other out. Show your work. And I will see you on Monday.